Hi everybody. This is a video that I'm creating, and we are here on the week starting on August 5. And I'm creating this video early in the week. Today is Monday because I received the project files and the Excel files from the team, so I want to comment on them and give you enough time to work more on them. It's very good that you're sharing these files with me now because they all have problems and they have to be addressed, and I'll show it to you. So let me take a look at first the one that was sent to me on the graduation rate data. So the team sent me only one project file, and that's what I want. I prefer to have only one that you choose as the best project file, or as the one you want to go with, and then I comment on that, and then you make changes or not based on my comments. In this case, you have to make changes, and I'll tell you why. When I look at your file, right? One thing that is not clear to me, even though you provided some description of the variables, one thing is not clear to me is what the unit of analysis is. I am assuming it's the cohort, but I need that to be clearer, because if it is the cohort, we have quite a few cohorts here. So it looks a little strange to me that we have so many cohorts to analyze, but it's possible. It cannot be the individual, right? Because you have in-state average tuition. So I'm assuming this is for the cohort. So what I recommend is that you change your data file and make it a little bit more like the ones that are provided on the course website that were used in my previous course and that I'm making available to you. And as you can see here, I have the data, and then in the description of the verb, you can ignore labels unless you have labels, which are text-based variables. This is labels that I created based on numeric data. If you don't have labels, or which are text data, you don't need to include them. But here in the description, there is a scenario and a question. So I suggest you have something like that for your analysis, so that I can understand what you're trying to achieve with the analysis, and add as much information as possible here so that I can understand also the unit of analysis that you are analyzing in your data set, and so on. Now let's take a look at the results. So we have one thing that I always look, and this is something that if you watch the videos, they're linked on the course website, you're going to see that I always check this to see if the levels of collinearity here, full collinearity, variance, inflation factors, if there is any one here that is greater than 10. And if you have, then you have collinearity in your data set that is above the level that you would want, and that is likely to lead to distorted path coefficients. So nothing here. Another thing I look at is whether you've done your analysis using the linear algorithm. That's always done on the example. So view general results. Let's see here. Yeah, you're using the nonlinear algorithm, warp 3. I will change that to linear. Let me do this. I will let you do that in your next version of your project file. But go to settings. In fact, I will change this I want to make sure I have your original file, so I'll just call this KOCK, and okay, so these changes that I'm going to be doing now are not on your original file. So I'm going to go change this to settings, and I'll change this to linear. We're going to do only linear analysis, at least to start with, in these projects. Otherwise, it becomes too difficult to interpret the results. We can keep PLS regression here, since all you have are single indicator latent variables. We could change this to robust path analysis, but I'll just leave PLS regression. It makes no difference. It just makes the computation a bit less efficient. So I'll save, and then now I'll have linear results, and they're similar to what we had before, right? So here's the problem I have with this data. It's telling us, and by the way, I would make it a little bit neater by having the main dependent variable on one side and then the other variables here. We tend to do this, and the reason for this is that if you have variables that you want to be control variables, then you just put them to the right. I'm assuming here that you expect, if you're putting these variables to the left and all pointing at graduation rate, that means that this is your main dependent variable, which is a good dependent variable. Graduation rate is very important for the university. And you're assuming that these are all predictors, and so these all cause this variable, and you want to know the order, right, of importance. So let's see what we got. We should get the same results as you had before. So let me just go and redo the analysis. Now, okay, so what this analysis is telling us is that these are not, a few of these are not very good predictors, like these two, right, which is fine. I mean, you're finding out that student to faculty ratio is not a good predictor of graduation rate, which is interesting. A DOD 8 is not a good predictor. GI Bill not a good predictor. Maybe because too few people receive these, right? Financial aid is not a good predictor. Well, it is significant, but the path coefficient is so low that it's a very weak predictor of graduation rate. Now you have the two main predictors here. Staff FTE, that's an interesting predictor, and it is interesting that this is much more important than financial aid. But look at this, right? This tells me that there is something wrong with the analysis, and it's probably in the choice of predictor, because what this is telling us is that the higher the average tuition, the higher the graduation rate. And this doesn't look like a common sense assumption to make, that this would be causing graduation rate. What this could indicate is that if we have, say, wealthier students in the cohort, the graduation rate is higher, or something like that. It looks to me like this is a marker of another variable. But this is something for the team to discuss and decide what to do. If there is a good explanation for this, then I think this is an interesting study. But we need to understand whether this is really a predictor or a marker of some other variable that is the true predictor, and just tuition is correlated with that other variable. Because this is odd, right? So tuition goes up, graduation rates goes up. I don't know. You might expect the opposite unless tuition is a marker of how wealthy the incoming or the cohort of students is, assuming that what we're measuring here is the cohort. So I suggest that the team take a look at this, make these changes that I made, talk about this, send me a revised data file, and we'll go from there, and also revised project file, and then we'll go from there. All right. Good. We're good in terms of time. Now, for the other team. So, several of the things, let me just make sure I save this. And let me check the other team. So, for the other team, my recommendation is that you sent me 3 files, right? So, let me take a look at them. Yeah, this looks messy. Revenue seems like an interesting variable. But in any event, for the other team, let me take a look at the data file. So yeah, I really need that scenario and a description of the variables. I cannot tell what those variables that you send me measure at all, right? So I need you to send me a revised data file with a scenario, question, and the variables, and I need to understand what the variables measure, how they fit with the scenario. I need to understand the unit of analysis also, right? So what is this? Is this the delivery? So each row is one delivery, or each row is a summary of deliveries done at a certain point in time. I have no idea what this international is. Maybe 1 means yes, 0 means no. So you can tell the problem here that I'm having, right? I cannot tell what these variables measure at all. I cannot tell what you're trying to achieve. And please send me only one project file, the one that you feel is the most likely the most likely one that you want to have for your project. So we have another one here that's just cargo. Yeah, this one the software is telling its level of collinearity is very high, but the other one has this problem as well. So let me show you what the problem is. So we got this. Yeah, let me see. Let me go back to that other one. Cargo Unlimited, I guess. Okay, so send me only one project file, whatever it is. This one I like a little bit better because we have all of the variables pointing at 1. That would be the main dependent variable. I would have it on the right, something like that, and I'll just leave it here, but I recommend you have it on the right. Once you define, it's already like that, so let me not change anything here. What I will do is I will change the settings a little bit, but you're gonna have to send me another project file. Okay, so but I'll just do a couple of things here so you see things you have to do. So one thing that I always look in this analysis, well, first let's go and make sure that this is linear. Yeah, it's not linear, so let's make it linear. So this is going to be a linear analysis. Linear analysis are easier to interpret. High collinearity, so I will show you where the problem is. Okay, so let's do the analysis even with high collinearity. So where's the high collinearity? It's here. So when you go to latent variable coefficients and look at full collinearity variance inflation factors, as I do in the videos that I shared with you guys, see, no number here can be higher than 10, and we have 3. They're infinite. Infinite means that each one of these variables is collinear with the other variables. Any number greater than 10 here is a problem. It would distort the results. And it's quite possible that the collinearity is among these 3. So let's say if I were to get rid of these 2 charges and QP, let's see if then this collinearity problem goes away. So I'll do that. I'm not recommending you do that because it depends on what those variables mean. That total may not be a good variable to have anyways. It may not mean much. It may not be the best dependent variable. But I'm gonna delete those 2 just to see if the collinearity problem goes away. Okay, so we'll see what happens. So now let's see those numbers. So no number greater than 10. So yeah, we got rid of the collinearity problem, and now we have more meaningful path coefficients. So if I go to path coefficients and p-values, if you have this better distributed, you may be able to see them. Right now it's crowding, right? So some on top of the others, but you can see them here. And the path coefficients, they look reasonable. So I guess you have reasonably large sample size, so even a small path coefficient like this one would be significant at 0.05. So here we have, this seems to be the strongest predictor of total. This is, I guess this is the strongest. Miles. That's interesting. It looks a bit like a project that a team did in the past. So I had a team that did a project like this in the past, and their unit of analysis was the individual delivery, and they would have things that they would have their main dependent variable, I think, was total cost or something like that. And I thought that project was very interesting. But again, I don't know what these variables mean, so I'll stop talking because I may be saying nonsense here. But this seems to be the strongest predictor. So we do have some predictors here that are stronger than others. So this seems like an interesting project, but I have to understand the meaning of those variables, because we may have the same problem as the other team here. One or more of these variables may be just a marker of something else and not a reasonable predictor of total, whatever total is. I don't know what total is. So bottom line, both teams have to revise their data sets and include more description there in scenario, more description about the variables. As I had requested before, send me their revised project files. Just send me one project file, the one that the team feels more comfortable with, and then we'll go from there. And as soon as I get them, I will try to prepare a video like this, commenting on the projects as quickly as possible. So thank you for doing this work, and we will be interacting more regarding this. Until then, thank you very much for watching.